So now that we've gotten the misconceptions out of the way, we're going to continue by looking into some of the history behind the theory of evolution, who was involved in the process, and what that process of developing this theory was like. But before we dive too much into the history, we have to consider what evolution really is. So we're going to go over some basic concepts and then dive into the most famous scientist dealing with evolution, Charles Darwin. And so the population is considered the unit of evolution. While I am a big fan of Pokemon, since that came out when I was a little kid and holds a special place in my heart, unfortunately, individuals do not evolve. When we're talking about evolution, we're talking about populations of organisms rather than individual organisms. And when we're looking at a population, specifically, we're looking at organisms that are the same species, living in the same space at the same time. And evolution is the genetic change that can happen in those populations from one generation to the next. So in essence, evolution is simply change over time. How does a population change after many generations? And we see that the individuals within the population that are born with certain characteristics may make them more likely to survive and reproduce successfully. So it's not enough to just survive and live a long life. It's more about, can you produce the most offspring over your lifetime? So the population is a group of individuals of the same species, in the same spot, at the same time, and as they go through changes from one generation to the next, they're experiencing evolution. Now let's get into the father of evolution, so to speak, Charles Darwin. He devised the theory of evolution by natural selection. Now, it's important to note that at this point in time, evolution itself, the idea that things changed over time, was not revolutionary. He was not the first person to put the idea of evolution out there. However, what Charles Darwin's contribution was the mechanism behind evolution, natural selection. Now, he was born in the early 1800s in England, and at the time, the Bible was really the main source of information about the natural world. And so while there were scientists who didn't necessarily agree with this, most civilians, most common people, thought that the Earth was about 6,000 years old and never changed. Now, at this point, we did recognize that there were many different species or types of organisms, but the common belief among most people was that all these organisms were created at the same time, never changed, and never died out. This was a point in time of discovery, where many explorers had been going out and been collecting specimens from all over the globe. So we did recognize that there were many different types of plants and animals and other types of organisms out there, but we didn't understand how these organisms came to be. But in the 1700s and the 1800s, we made some major scientific advancements. So again, most of the common people, common civilians, didn't necessarily have access to all of this information right away, but scientists were making leaps and bounds. We found from Georges Louis Leclerc that the Earth had to be at least 75,000 years old, because that was the minimum time required to cool from the molten state. So we've changed now in terms of how long or how old we thought the Earth was. Were we still far off from the actual age of the Earth? Yes, but this was progress. We also started to find fossils. So Georges Cuvier started to find fossils that were unlike any of the living species we saw at the time, including giant fossils of elk, mastodon, the giant ground sloth, so on and so forth. So the idea that organisms had existed that did not exist in today's world was starting to come to fruition. However, Cuvier did not agree with the idea of evolution, but he did think that organisms could go extinct or disappear forever. And so here are some of the examples of organisms that we found fossils of that no longer exist. We see the scale, right? So here's like an average man in their height. Here's the Irish elk in its size, the mastodon, and the giant ground sloth. These were massive organisms, massive animals, what we would call megafauna. But none of these exist anymore, right? We do have evidence, though, in the form of fossils. And we'll get into what fossils are in just a little bit. Now, we started to think that maybe species could change over time, and that was Charles Darwin's grandfather who's starting to throw this idea out there. So again, the idea of evolution was not Charles Darwin's idea. He was looking at the mechanism, but we started to see in the years preceding him that we were introducing the idea species could change. One of the famous minds to kind of speculate why or how these species changed was Jean-Baptiste Lamarck. He thought that species changed due to use or disuse of a trait. Now, was he correct? Not really. Right? He had the idea that species change correct, but the reason of how they changed was wrong. That being said, he did start to open up doors to lead scientists to kind of question these previously kind of sacred truths people held. So we're starting to see ideas come out and scientific minds thinking about how species really are. Are they concrete and unchanging, or do they fluctuate in terms of what traits we can see in them over time? Now, there's been gradual but relentless, so unstoppable geological forces that had shaped the Earth and continue to do so. That was Charles Lyell's idea, that the geology of our planet, right, there were forces that were gradually changing the Earth around us. And all of these things kind of were brought together and helped Darwin kind of shape his own ideas, that not only was the Earth changing, but that species were changing the same kind of way. Now, I do want to bring up Jean-Baptiste Lamarck again, because both he and Darwin had the same types of idea in that species changed over time, but the mechanism was the part where they differed. Darwin, we now know, is the mechanism was natural selection, which we'll get into in just a little bit. Lamarck's idea was the use or disuse of a trait. And just to kind of give you an idea, basically, if you used a trait or if you changed something about yourself, then you could pass those changes on. So the common example is giraffes, in that you had a bunch of giraffes that all had short necks, and because the food was so high, they continually had to stretch their necks upward, reaching and reaching and reaching, and that as they did that, that somehow would lengthen their neck, and that when they had their own offspring, that lengthened neck somehow was passed on. So another way to think of it is like if you dyed your hair purple and then had a baby and your baby had purple hair, right? So we know that that's not really the case, but he kick-started the idea that species were even able to change in the first place, which was a big leap forward. But let's continue on with Charles Darwin and his journey. Now, he was obsessed with nature, right? I'm not going to necessarily test you on the process or the places like he went to and the journey he made. We're going to focus more on what he found and what his ideas were based on what he found. So, some important things and observations he made. One, he witnessed an earthquake, and this earthquake was massive and shifted parts of the Earth over an entire meter. That's 3 feet, basically. So if that was the case, if an earthquake could shake the world and shake the ground so hard and so much that the Earth literally shifted under, several feet, how could the Earth be static? Something was causing change with the Earth itself. And we could apply this to animals and plants and other organisms as well. He also found fossils of marine organisms, so oceanic animals and plants in the high mountains. How did they get there? These are some of the things he was thinking about. How could you get aquatic life, ocean life, at the top of a mountain that did not have any sort of water source even close to an ocean around it? He also, one of his most famous ones is probably his observations of the species of finches on the Galapagos Islands, where they were all very similar, but they had some slightly different traits from each other. The main one was the beak shape. He noticed that these finches all looked pretty much the same except their beaks were slightly different. He also saw that these finches resembled the same types of birds found on the mainland of South America. So we saw that the mainland birds and the island birds were really, really similar. And that he found fossils that resembled modern living organisms. So why would we find fossils that resembled things that were still alive today? So let's go ahead and look at some of his observations. So the Galapagos Islands are just off of Ecuador, and there are finches found both on the mainland and on the islands. They're very similar with the exception of their beaks. And so we see some of the different island finches. Again, the Galapagos Islands is kind of a collection of several small islands close by. And we see that all of them look like the mainland finch with exceptions to the beak. Right here we have kind of a generic beak, and then we see that this one's really large, this one's more similar to the mainland, and then this one's very narrow. And what it came down to was the type of food available on each island. So those that had very large, hard to crack nuts and seeds, the ground finch beak would be much better for that. If you had something very delicate and small, right, then these guys would do a little bit better. And if you had to poke and prod maybe to get insects inside of a tree branch, something long and thin would be even better. He also saw that there was a resemblance between the extinct species and the living species in the same area. So the Glyptodont is an extinct, a large armadillo-like species, massive. We're looking up to 10 feet long and 4,400 pounds. And while it's massive, it looks very similar to the armadillo we see today. That is understandably much smaller, with weighing only a few pounds and only 1 to 2 feet long. But even then, even with these massive differences in weight and length, we see the similarities in their body structure and some of the various traits they have, like this kind of armored back. So why would you see extinct species that are so similar to the species that were alive at that moment? So what Darwin thought, taking all this information in, is that individuals of a species were more likely to, quote, win at what he called the, quote, struggle for existence. He wrote about it. He worked with another person to write about this, but he didn't publish it right away, even though the manuscript was complete. It wasn't until 1859, years later, that he finally published his book on the origin of species by means of natural selection, although most people may know it as simply On the Origin of Species. It was an instant bestseller. It did very, very well and changed the way a lot of people thought about how organisms were related and changed over time. So again, even though we're in the 1800s, people were coming around to this idea that evolution was a thing and that natural selection was a mechanism that allowed evolution to happen. So it's interesting to see that we still kind of struggle with some of the misconceptions we have today, given how long this idea has been around, how long it's been considered a theory, and how long many people have simply accepted it. So if we look before Darwin and before most of the work done looking at evolution as a concept, before that, pretty much people, the average citizen, thought organisms were put on Earth by a creator, that some sort of creator, and that all of the organisms were put on the planet at the same time, that these organisms were fixed, nothing changed. We didn't add traits, we didn't lose traits, that the Earth was only 6,000 years old, and that the Earth really never changed. After Darwin and other researchers who contributed to this concept, we saw that the common idea was that organisms did change over time, that there were organisms out there that did go extinct, that died out, that the Earth was well over 6,000 years old, and that the geology of the Earth was actively changing all the time. So this was a big shift, and the origin of species was a catalyst in that shift in ideas.